Alright, today we're going to talk about gas laws, specifically Boyle's Law. And Boyle's Law relates pressure and volume. If you've ever taken a bag of chips and driven up over the mountains and watched it expand, you've seen Boyle's Law in action. So let's get our settings going here. Next slide. Alright, we see Boyle's Law simply stated as pressure times volume equals a constant. Okay, so we see the mathematical equation of P times V equals K, with K being the constant. If we look at the graph, we're going to see pressure on the x-axis, volume on the y. So if we go to a pressure of 1, our volume is measured at 60. So the constant here is 60. Okay, 1 times 60 is 60. So if we go to 2 atmospheres, we see 30 milliliters, so 2 times 30 is 60. And continue on, and we could pick any spot. If we look at 6 atmospheres, we're going to see that it's 10 milliliters, or 60, or 6 times 10 is 60. Okay? So that's what we mean by a constant. Okay? So if we look at really a usable version of this equation, the kind we'll use to solve these problems, is P1V1 equals P2V2. Okay, which 1 just means initial or starting conditions, and 2 is the final or ending conditions. And one other thing we can say about Boyle's Law is that pressure and volume are inversely proportional. Okay? Boyle's Law shows that as pressure increases, volume is going to decrease, or as pressure decreases, volume increases. We can see that represented in this picture. Here we have a high pressure with a lower volume. As we increase the volume, we're going to lower the pressure. So let's look at solving some of these equations. Okay. So if we have a sample of gas at 2 atmospheres, it occupies a volume of 2.5 liters. What volume will the gas occupy if the pressure is increased to 4 atmospheres? So we'll just go through the equation and find out what we have. Okay. We start and just try to identify the various things in the equation. Do we know the initial pressure? Well, we read it says a sample of gas at 2.00 atmospheres. Well, we know atmospheres is a measure of pressure, so that is going to be our initial pressure. Okay. Do we know the initial volume? Well, it says it occupies a volume of 2.50 liters. So pretty much tells us directly, but we also know that liters is a measurement of volume. Okay. Do we know P2? Okay, that's the final pressure. It says what volume will the gas occupy if the pressure is increased to 4 atmospheres? So we see that we have a final pressure of 4 atmospheres, and it says, and it did say, oops, sorry, pen problem, it did say what is the final volume. Okay, so our V2 is what we don't know. Getting a lot of jumping. Okay, so we're trying to solve for V2. Okay. Well, if we look at this equation, if we solve for V2, we're just going to divide both sides by P2. Okay, so we see on this side they cancel. So we are left with the equation of V2 equals P1 V1 over P2. And then we just plug in. Okay, our initial pressure, or P1, is 2 atms. I'm going to drop the zeros because I'm having problems writing here, but we'll remember those when we're writing our answer for significant figures. So our P1 was 2 atmospheres, our V1 was 2.5 liters. Okay. Our final pressure, or P2, was 4 atm, and we solve this, we get an answer of 1.25 liters. We'll notice that in our equation, our units of atm canceled. We were left with units of liter. Okay. So we have to make sure our pressures are in the same units. Likewise, if we had the 2 volumes, we would have to make sure they were in the same unit. So let's check our answer. Okay. As we said, as pressure increases, volume should decrease. So our pressure increased from 2 to 4. Our volume decreased from 2.5 to 1.25. If we look even a little bit closer, we see that pressure went from 2 to 4. So we can say the pressure doubled. If the pressure doubled, our volume should be cut in half. So 2.5 in half is 1.25. So we are good. Okay, so that's solving Boyle's law. We'll do one more practice if you want to stick around. Okay, so here we have a sample of gas at 0.14 atmospheres. Occupies a certain volume. What is the initial volume? Okay. So we are given an initial pressure. So our P1, 0.140 atm. Our initial volume is what we are looking for. Okay, our P2, we keep reading the question, we say the pressure is changed to 760 kilopascals, and our new volume is 143 liters. Okay. Well, what we're going to see, as I was mentioning, that we have to have pressures in the same units. Here we don't. So I'm going to convert pressure 2 of 760 kilopascals. I'm going to convert that into atmospheres. I could have just as easily converted atmospheres into kilopascals. It wouldn't make a difference because the units are going to cancel. I seem to have lost my pen here. Okay, there it is. 1 atmosphere. We know that 1 atmosphere is 101.3 kilopascals. So those cancel. We've got our units here. We're going to see that that is...
Mary Trujillo, please call extension 0. Mary Trujillo, extension 0, please.
I see that is 7.50 atmospheres. Again, I'm going to drop the 0 for right now, just because of my pen problems. So we're going to see the pressure increased quite a bit. Okay, so it went from 0.14 atmospheres to 7.5. Okay, so the volume would have had to decrease. So our answer should be higher than 143 and substantially higher. So we're looking for V1. If we go back, this is our equation. Okay. If we want to solve for V1, we're going to divide both sides by P1. They'll cancel out on this side. We're left with V1. We call that isolating the variable. Okay. We've got V1 equals P2, V2 over P1, and at this point it's just plugging in. So our P2 is 7.5 atm. Our V2 is 143 liters, and our P1 is 0.14 atm. We see that these pressure units canceled because we went in and converted them to the same, and to 3 significant figures we are left with 7,660 liters, okay, which is quite a bit higher. So our volume did decrease as anticipated, and that is Boyle's law.
If you can dodge a wrench, you can dodge a ball. What?